Hi everybody, this is Cal with section 3.1, sequences and their limits. What I'll say first off is that chapter 3 in general and this section in particular are extraordinarily fundamental to the rest of the course. We're spending an entire week on this one section and there's a good reason for it. You really need to understand how to prove the limit of a sequence in order to understand basically anything we do in the next 3 chapters and onward. This is just absolutely fundamental to the rest of this course, to understanding calculus on a theoretical level, to any analysis sort of course that you do in the future. So we start off this section by defining a sequence. You absolutely need to know what a sequence is and how to work with it. That being said, you really don't need to have this definition. I mean, I didn't list it on your flashcards. I'd rather you have a good working sense of what a sequence is, but you certainly can deal with it as a function from n to r. The book has a couple of examples of sequences, including recursive sequences. Those can be interesting. I urge you to go through the examples in 3.1.2, and there's some good stuff there. Now, in the middle of 56, we define the limit of a sequence. This you absolutely need to have memorized by heart. If there's like one definition that you really need to know this term, this is probably it. I don't know if I had enough reallys, but hopefully you get the idea. You should definitely be familiar with the terms convergent and divergent. And I really like this little note that it has right under the definition about the notation k of epsilon, and what the of epsilon means about k. But that note in general is really good. There's a little bit of notation right below that note. That's good stuff. We will use all that stuff. And 3.1.4 is an important theorem. I would read the proof if I were you. It's an easy proof. It's a really good demonstration of how we prove things about limits, although we'll have plenty of time for that sort of thing in section 3.2 next week. Okay, so at the top of 57, it reminds you a little bit about neighborhood notation, and Theorem 3.1.5 gives you a few different ways to state the property that the limit of a sequence is little x. And these are all useful things to use from time to time. Make sure you understand why they're all saying the same thing. The proof is short, but important to understand. And the note below the proof is also important. This remark over here is also important. What we're talking about here is proving that limits exist. What we're not talking about is determining what the limit should be. I mean, really, you should know what the limit should be from calculus or from just getting an idea of what the sequence looks like. But a computation is not a proof, and that's an important remark. We have examples in 3.1.6. Those are important. I would go through them. You can see a use of the Archimedean property, an immediate use of the Archimedean property in part A. And make sure you read through parts B and C as well. I really like example C. It's great. Example D is bog standard as well. These are all things that we need to use. Now in example E, it's using elementary properties of the natural logarithm function that we haven't proved, but hopefully you know how logs work from previous courses. So you can kind of run with that. So the examples are nice. Read through them. Hopefully you can understand where they're coming from, but we'll spend a lot of time on that in class. I really like the remark at the bottom of 58 about the k of epsilon game. Read that carefully and understand what it's getting at. And that goes on to the top of 59. Now, there's a note at the top of 59 and an example following it about showing that a sequence does not converge to a particular number. So getting into the negation of the definition of a limit of a sequence, and that's also a pretty important thing. From the middle of 59, we get into this idea of tails of sequences. Basically, what happens if we only look at the sequence after a certain term. And that can be a useful tool. Make sure you know the definition and the theorem that follows it. The word usage of ultimately at the bottom of the page. These are all pretty standard things and good things to know. And then we have further examples starting on 60. There's a short theorem, 3.110, which is an important theorem. It's kind of a comparison theorem of sorts. Make sure you understand what it's saying. And the proof is pretty quick. And then there's examples for the rest of the section. These are slightly more in-depth examples than the previous ones. Some of them actually invoke earlier examples, like Bernoulli's inequality and so on. And I recommend that you read through those. C and D in particular are pretty interesting examples and ones that you might want to try to get a handle on. And that's your reading for this week.